Friends, we have learned about various gear manufacturing process and mostly we have studied about the machining processes. But there are some other processes which you can use to produce the gears of various sizes, shapes and accuracy. We have a common method which is known as the casting method. So you all know with the help of casting technique, we can also produce products of various shapes and size. And the simplest method is our sand casting. I'm not going to explain the sand casting in detail, but I can give a brief description about this sand casting. That in sand casting, you have a mold cavity which is made up of sand, and this cavity is made up of sand and certain binders, and it is carried out in a flask which has particular two parts. One is the cope and other is the drag, and there is a cavity of desired shape and size. And what you do, you melt your work material, uh, and then you heat it, and then you pour it into this die cavity, and then you let it to cool down for some time. And after the solidification, what you do, you take out that cast product by destroying the mold cavity. The sand casting is a process which is used to make the iron gears for low speed farming machinery. You can say the accuracy and finish is not a very important factor in these types of gears. You can see we have different types of components. You might have seen in somewhere in your, if you belong to some village, you might have seen this type of structures for farming applications. You can see this much of the big size gear. It is not possible. It's very difficult to produce gear of this much size with the help of machining process. And this heavy big gears, you can say, for different applications for low speed, and you can say addition when you have to lift heavy loads, but the working speed is very less, such as in this case it is a figure which shows crane which is used to lift the loads with the help of this gear mechanism and this pulley system. Similarly, as another type of lifting mechanism which is having a steel rope or steel wire, and you can see it's also used for some mining applications for dig out some dirt from the ground. And this is some kind of another big gear of very big size, but the shape is very simple. And you can see the finish and accuracy is not a matter. It's not a point to consider. So sand casting is a process which is used to make the gears of cast iron for low speed applications, and your accuracy and finish is not an important criteria. Then we have another process which is called die casting. You know that in die casting, dies or the molds of materials like tool and die steel, and some high temperature resistant materials like tungsten, molybdenum or graphite. And here the filling of your metal into the die cavity is under the pressure. This process is used for mass manufacturing of low melting point metallic gears. The metals can be aluminium, magnesium, zinc, copper for low loads and moderate speed. But you can see the finish and accuracy is far better than the sand casted gears. And their applications are small gears in cameras or toys. We have two types of die casting processes. If you remember from your manufacturing class, one is cold chamber die casting process and other is the hot chamber die casting process. And hot chamber die casting process, you can say, is it's adopted for low melting point materials like zinc and magnesium. If you can see this figure, if you remember, then there is a arrangement which is having a goose neck. This is a special type of structure which is used in the hot chamber die casting process. So in this case, you have a reservoir which is filled with your molten material, and this arrangement which is having this chamber and special pathway for the entry and then feeding of your molten material into the die cavity. So these die cavities are controlled with the help of machines, and these dies are available in two parts. These are basically known as split dies. And in the first case, you see that your dies are in the closed positions, and this plunger has moved upward. so that it has created a suction in this particular chamber, which allows the metal to enter this chamber. So this is the first step, and in the second step, then this plunger is pressed into this chamber under certain pressure, which ranges from 7 MPa to 140 MPa, and then with the application of this pressure, the metal is squeezed into this particular, you can say, channel, and then it is fed inside the die cavity, and then you allow it to solidify for some time. And in the final stage, the die opens up, and with the help of this ejector pins, you have these two ejector pins to eject out the solidified component, and simultaneously this plunger moves upward, and then it also gives pathway to enter your molten metal into the chamber. And this type of feature of any shape and size, if you keep your die cavity in the shape and size of a gear, so the final product comes out in the form of finished or semi-finished gear. And you have another process which is called cold chamber die casting process. Here the chamber in which your molten metal is poured, it is separated from the heating, you can say, the reservoir. And this process is used for somewhat high melting point materials like you can say magnesium, aluminium, and copper. And in the first step, again you see that your dies are in the closed position, and then with the help of a ladle or funnel, you pour your molten metal into the short chamber. So in the short chamber, you pour your molten metal, and with the help of this ram, or its another name is called plunger, you press or you squeeze the material under pressure, and with the help of this pressure, your molten metal reaches into this die. And then in the third stage, these die cavities opens up, and with the help of these ejector pins, you eject out the solidified component. So these are two different types of processes, and you have gears produced of higher accuracy and higher surface finish as compared to the sand casting process. So this is a very brief discussion about the die casting process. Then this is another very interesting process which you have already studied in your previous classes. Its name is investment casting or lost wax method. So it is a kind of near net shape process which requires less or no finishing in the solidified product, and it is used to produce the gears of small to medium size with very high degree of surface finish and accuracy. And then such types of gears can also be used for heavy loads and higher rotating speeds. So what happens in this case, in this process, you have a wax pattern. You know that wax is a very soft material, and any shape can be easily imparted to this material. So you have a wax pattern, and the wax used can be of paraffin wax or beeswax. Nowadays, this paraffin wax is popular, but in olden days, people used to use the bee wax. So the bees also produce wax, and you prepare your wax pattern, and a wax tree, you can say a pattern tree, is also made. This tree is, you can say, you have a sprue or the pouring channel. It is also made up of the wax, and then by melting of the wax, you attach this wax pattern to this tree. And then in the third step, what you do, you dip this bunch of pattern into a bath which is having a ceramic material. So this ceramic material forms the coating over this wax pattern tree in the fourth, and then you allow it to solidify and then allow it to rest for some time, so that the coating develops or sticks to the surface of the wax patterns and the tree. And then it is inverted in the fifth. This pattern tree is inverted, and then you heat it from the outside. So from this particular opening, which is intentionally created in this particular structure, so with the help of this, you can say the opening, the heat basically melts the wax which is filled inside this pattern tree, and then its wax flows out from the structure, leaving the, you can say, hollow structure behind. And in the sixth stage, you see, you fill up this particular pattern, or you can say the cavity, with the help with your molten metal, and then you allow it to solidify. And finally, when it acquires the required shape and size, after a few hours, then you break this structure, and then you can easily take out your cast product from out from it. So this is the, you can say, the actual diagram or the real figure which shows that you have this particular pattern structure which is having multiple gear like, you can say, the features. In the sixth here, you fill your molten metal inside the cavity, and then you allow it to solidify for some time, and then in the finally in the seventh stage, what you do, you break out the structure, and then you take out your solidified gears or any type of solidified product. If you like the, then please subscribe to my, share it with your friends, and don't forget to hit the bell icon for the latest updates. Thanks for watching my videos.